All right, so our next section is RC4, Objective 4, deals with quadratic functions and equations, writing and solving. Why is this showing up? Sorry. So I'm just going to go over key facts. You have to remember that a quadratic equation is the shape, the graph here, this curve is called the parabola. Standard form is when we have y equals x squared plus bx plus c. When solving, we need it to be in standard form and it has to equal to 0. The basics, the parts that you're going to have to label and identify are the axis of symmetry here. That is, let me fix this real quick. That is this dotted line that is going through, and maybe I should keep it dotted. But it goes through the middle of the parabola and it goes through the vertex. We expect you to also know these intersection points right here are your x-intercepts, which are also known as your solution, your roots or your zeros. We also have this point here is your y-intercepts, and no, that hasn't changed whether it's linear or quadratic. And then, of course, this point, the bottom point or the top, depending on your parabola, that is your vertex. So you need to know each part. Some of the key basics is that if you're in standard form, the C in the standard form is your y-intercept. Okay, the C represents the y-intercept. Also need to understand your axis of symmetry. So our axis of symmetry, we do have a formula for that. Negative b over 2a. That means you would be using the b in the standard form and the a in the standard form into that formula to use that formula to calculate it with pencil and paper. But what's important here is you recognizing that if a is positive, you're going to have a minimum because it opens up when it's positive. And if a is minimum, a negative, you're going to have a maximum because it opens down. And just realize that your order pair are your vertex, and I probably should have did that in green. Yeah, because vertex here is an order pair. It's the same as your x as the axis of symmetry. So just some characteristics. Understand that your A tells if the parabola opens up or down. Anytime I see it open up or the arrow's pointing up, I know my A is positive, which means I'm going to have, really this one's written backwards, sorry, which means your vertex is a minimum here. And they're just showing you in vertex form that would be your H and your K. If your A is negative, that would mean that the parabola is pointing down, and you would have a max here. And sometimes you're going to have a min if it opens up. These are kind of backwards. So the thing that we would expect you to do from this graph is identify the range, because your domain is all real numbers for parabolas, all parabolas. So if it's opening up, this would be y is greater than or equal to. This is the k is your y value, so whatever k is. And this one would be y is less than or equal to whatever the k value is. So this example was given to you in a prior section. And just remember that from here, we know domain is always all real numbers, but you need to find that this has a minimum and what that minimum value is. Minimum value is the -3. Since this is opening up, this would be written as y is greater than or equal to -3. And they just kind of showed that in what words. All real numbers greater than or equal to -3. Now, other basic facts that you need to recognize is a transformation. Most transformations we can identify in vertex form, which is x minus h parentheses squared plus k. So on this section, transformations, vertical shifts go with the k in the vertex form. if I'm adding a c, I know they're saying c in regards to the parent function x squared. Anything that's positive or plus, that means it shifts up, c units up, whatever the c is. If we have minus, that's c units down. Okay, so here, this is x squared is our parent function. And then if you notice here, we have minus 2. So that's why they're telling you we had a shift down 2 units. The blue to the red was a shift down 2 units. Now, they're asking you to find the shift between the red, or the red and the blue. Okay, so if I just kind of focus on the vertex here, this vertex is at +1, this vertex is at -2, and if I look at the units between them, that is 1, 2, 3 units. That's why this is showing a shift up 3 units. Now, besides shifting up and down, vertical shifts, you're going to need to also recognize horizontal shifts, which are not shown here, and that would be the H here. And also you would need to recognize when we have a horizontal compression. So that is when the coefficient of A is greater than, so when we're always positive or small to a larger number means that it gets narrower. So this one was just 1 and went to 3. That's why the red is showing narrow. Now horizontal stretch, again, if you're looking at the coefficient, but when A is a fraction, it's going to get, or between 0 and 1, it's going to get wider. So like this -1/4, excuse me. So they're showing you that this red parabola got wider than the parent function, the blue one. So on the last page of practice here, you're going to use these facts to help you problem solve. If you forgot what those items are, you come back to this page. But the first thing is, on this first example, we need you to be able to fill in every part here if you're given a function. So I want you to hopefully remember that I can change this f of x to y equals. So if I go to my calculator and go to y equals, type in the equation, which I believe this is it, x squared plus 2x minus 3, graph it, get an idea of that graph, or to get better exact points, go to second graph to go to the table. Remember, in the table, we want the vertex, and that's where we see the pattern, the numbers repeating right here. So it repeats right here. So there's my vertex. It's at -1, -4. So this is going to help me when I'm sketching my graph. So when I go to, the vertex we know is at -1, -4. So -1, 2, 3, 4 is like right here. Then the pattern is 0, -3, and then 2, -3. And then if we look again at our values after that, -3, 0, and at 1, 0. So when I go to -3, 1, 2, 3, 0, and at 1, 0. So we're going to just sketch. I'm just going to sketch the parabola going through these points, and then we're going to fill in each part. So would this graph have a max or min? Since it's opening up, it's going to have a minimum value. All right. What is that minimum value? How low does it go? It goes to a -4. So there's our minimum. Our x-intercepts, or our roots, okay, that's where it touches the x-axis. So these are at -3, 0, and 1, 0. Axis symmetry, that's when the parabola gets cut in half and it goes through the vertex. So it would go through like here. This would be x equals -1. Our y-intercept we can physically see on the graph here is where it touches the y-axis, and that is at 0, -3. Our range deals with our max or our min. We have a min here, and it's at a -4, so our range is greater than or equal to -4. Domain is always all real numbers. All right, so we're going to take this scale and apply it to some problems. Okay, now on this one, they want you to put it in standard form. This is in vertex form, so we have to remember, let me get my font, to expand this first. So this would mean -2, parentheses x plus 2, x plus 2. We got to write that twice, then -12. Here, we need to do the FOIL of our two binomials, okay? The first, so we keep the -2 in front. We're going to have x squared plus 2x plus another 2x, then plus 4, then -12 outside the parentheses. And we should recognize to combine these like terms here. So the -2 stays in front. We got x squared plus 4x plus 4, and then -12. So now what needs to happen, hopefully you recognize, you need to distribute now. Oops, that one and then that one, sorry. So this gives you -2x squared minus 8x minus 16, and then we had this -12. No, sorry, not -16, -8, sorry. Then the -12. So now we can combine these like terms, get it in standard form, which is a -2x squared minus 8x minus 20. Okay, so since it said it's in standard form, it had to look ax squared plus bx plus c. That's what we just kind of reviewed. Now, this has had the most questions, the linear factors. Factors is when we have parentheses. Okay, our factors correlate with the intercepts here. So because this is at a -3, my linear factors, sorry, are x, you do the opposite, x plus 3 and x plus 1. Those are the factors. So factor form would be y equals x plus 3, x plus 1. Okay. Now, standard form, that means we're going to take these factors and do our FOIL to put it in standard form. So, excuse me, this would be x squared, then plus an x, then enter right here, plus 3x, plus 3. So we combine our like terms. Standard form is x squared plus 4x plus 3. So plus 9. Okay. They're not going to ask factor form, but they're definitely going to ask standard form. So now, so this is in factor form, and they want you to find the roots of the function. So the roots are your solutions. And basically, to get to your solutions, you make each parentheses, meaning my x plus 6 equal to 0, and you make, hold on, let me make this better. 6 equals to 0, and you have your x minus 9 equals to 0. So you're solving for x, and some of you already know the solution is always the opposite of what's in the parentheses, but just to show you, so if I minus 6 here, we get x equals a -6. So instead of plus 6, it's a -6. Instead of minus 9, it's a positive 9. So our roots or our solutions are B, -6 and positive 9. Now, so I think I'm missing something in here, and I am. So hold on, let me get to the graph because I just realized it's missing. Okay, so I had to add this picture so we can say, because I believe on your packet you do have the picture. And so they said, how much time elapsed while the rocket is 1250 or 1,250 meters above ground? So if I kind of find, basically, I need to know is 1250. So I'm not sure if you see that there are increments in between. So this would be 250, another 250 is 500, this would be 750, then 1,000, then this is going to give me 1,250. So here's the 12. So it happens twice in 2 different locations. But since they want to know how much time elapsed while the rocket's is 1250 above ground. So basically, once we get at 1 second, right here, from here to here, during our time, from 1 second all the way to 5 seconds, it's above 1,250 meters above ground. So this would be, basically, we just take the range of that 5 minus 1, will be 4 seconds above. 4 seconds, the time elapsed, that it's at 1250. And then here, how would the graph of the function y equals x squared minus 3 affect the function y equals x squared plus 2? So you could go back to your calculator and compare them. So you go y equals here, I'm going to clear this out. We had x squared plus 3, no, minus 3, sorry. Okay. And we're comparing that to x squared plus 2. We're in a graph. And so my blue is the first equation, minus 3 right there, and then the red is my second equation. So how is it affected? The shape is it's the same. Nothing changes as for the shape because of the coefficient. There's no coefficient here. So hopefully we see that this graph moved up 1, 2, 3, 4, 5 units. So the graph would shift up 5 units. Okay. All right, so that takes care of objective 4, and then we're going to get into the last section, objective 5.